What if I say that everything we call secure is based on a mathematical lie? Today we are exploring why our RSA and ECC encryptions are essentially dead on arrival. Now picture this, every secret message you have ever sent, every password protecting your future college apps or bank account, every secure website you log into, all of it cracked wide open overnight. No hacks, no phishing, just math winning. This is not a movie, this is the quantum apocalypse. And experts say the warning lights are flashing right now. Welcome to the 2026 quantum apocalypse. Is your IT security already dead? Today we are diving deep into why quantum computing is about to rewrite the rules of cybersecurity and what that means for you. Stick around, and by the end you will know if your digital life is already on borrowed time. First things first, what even is quantum computing? Your phone or laptop uses classical bits, tiny switches that are either 0 or 1, like a coin that is head or tail. Quantum computers use qubits. Thanks to quantum mechanics, the weird rules of tiny particles, a qubit can be 0 or 1 at the same time. That's called superposition. It's like a coin spinning in the air, both heads and tails until you look. And qubits can get entangled, link up, so one state instantly affects the other, no matter the distance. Einstein called it spooky action. Result? One quantum computer can test millions of possibilities at once. Classical computers, they do it one by one, like checking doors in a hallway. Quantum, it checks the whole building at the same time. Research from IBM and Google shows we are hitting real milestones. Error-corrected qubits are coming fast. By 2026, cloud quantum services are exploding. But here's the scary part. This power doesn't just solve problems, it breaks security. As we all know that traditional IT security is built on hard math. Most of the internet security, HTTPS, banking apps, VPNs, relies on two big math problems that are insanely hard for normal computers. First, RSA encryption. It uses two massive prime numbers multiplied together to make a huge public key. To crack it, you factor the huge number back into primes, a 2048-bit RSA key. Huge number. Classical computers would take longer than the age of the universe. And the second one is elliptic curve cryptography, ECC, used in Bitcoin wallets and secure chats. It hides secrets on a curved math graph, solving the discrete log problems. Here is like finding one specific point on an endless roller coaster track. These are not encryption in the spy movie sense. They are math puzzles so tough even supercomputers give up. But quantum changes everything. So what makes quantum so dangerous? And what is its killer weapon? It's Shor's algorithm. Enter Shor's algorithm. It was invented in 1994 by mathematician Peter Shor on a big enough quantum computer. It turns factoring and discrete logs into an easy mode. How? Quantum parallelism and clever matrix. It finds patterns in huge numbers that classical computers miss. Real talk from recent research shows that breaking a 2048-bit RSA key might need just 1 million logical qubits. It seems very big amount. It's tough but doable with error-correcting advances. IBM's roadmaps and Google papers suggest cryptographically relevant machines by the early 2030s. It is near. And some optimists say that it can be invented in 2027. Governments and hackers are already scooping up encrypted data today, waiting for the quantum key. And your 2025 Zoom call was safe. Yes, it is safe now, but in 2032, maybe not. So the traditional security is dead, but new math is rising. Enter lattice-based cryptography, the star of NIST's post-quantum standards. A lattice? It's like an infinite grid of points in high-dimensional space. Think a 3D chessboard stretched into 500 plus dimensions. It's scary. Points are made by adding vectors, arrows from pieces like Lego instructions. Here's the math. Imagine a two-dimension for starters. Basis vectors v1 and v2. And in this space, both vectors v1 and v2 can be uniquely represented as a linear combination of 2, 0 and 1, 3. And we can calculate the coordinates of the specific point. But here comes the lattice points. All combos like 3v1 plus 2v2 and the coordinates are 8, 6. In higher dimensions, finding the shortest vector SVP between points is brutal. Or the closest vector CVP. Classical computers, good luck. In 500 dimensions. Quantum, still super hard. No, Shor's shortcut here. The real star. Learning with errors. You get noisy equations like A into S plus E is equal to B. Where's a tiny random error? E is a tiny random error. Solving for secret S. Easy if you know the noise pattern, but in lattices, it's like finding a needle in a haystack that's on fire. Quantum computers can cheat this reliably. NIST picked lattice winners. ML, KEM, Kyber for key exchange, ML, DSA, lithium for signatures. They are fast, secure, and ready now.
2016. NIST launches post-quantum crypto project. 2022. NIST selects lattice-based finalists. 2024. First PQC standards, FIPS 203 to 205, published. 2026. EU and US ramp-up mandates. Quantum cloud access. 2030. RSA ECC deprecated. NIST deadline. 2035. Full PQC required. US NSM 10 goal. 2026 isn't the end, it's the wake-up year. By 2030, your school's Wi-Fi or future job systems could switch. But start prepping now. So, is your IT security dead in 2026? Not yet, but it's on life support. If you're building apps, using VPNs, or storing data, yes, long-term stuff is vulnerable. Action steps for students and future pros. 1. Learn PQC basics. Try Kyber in Python demos. 2. Push for quantum-safe tools. Signal, some browsers already testing. 3. Careers alert. Post-quantum security jobs are exploding. Governments are moving. Companies like Cloudflare and IBM are deploying Lattice crypto today. You can too. The 2026 quantum apocalypse isn't about panic, it's about power. Quantum computing will solve climate models, cure diseases, but only if we secure it first. Traditional IT security. It's evolving, not dying. Lattice math and PQC are your new armor. What do you think? Is the apocalypse here, or is this humanity's upgrade? Drop comments, share this with your class, and stay quantum aware. Thanks for watching. Your future digital self will thank you. See you in the post-quantum world. Credits roll with sources. NIST, IBM Quantum, Global Risk Institute reports.